Jerry has many cells in his ectoderm, and they have to figure out if they will become spikes or not. This is done with a biochemical pathway in each cell. The cells start with S, and this stimulates production of P. But if this P is mutant, then it would never be made, meaning that I would never be stimulated, and I wouldn't inhibit K, so K wouldn't inhibit E, and spikes would not be made. Next is if I was mutant. S would stimulate P, but P can't stimulate I since it is mutant, so I cannot inhibit K, which means that K is able to inhibit E, meaning spikes would not be made. If both I and E are stimulated, then S would stimulate P. P wouldn't stimulate I, so I cannot inhibit K. So K is able to inhibit E, which would mean no spikes. But because E was mutant in the first place, there was never anything to stimulate spikes, so without either, spikes would not have been made. Lastly is if S and K are mutant. Without S, P can't be stimulated, meaning I wouldn't be stimulated, so I wouldn't repress K. But since K is mutant, it cannot repress E, meaning spikes are made. This shows that S, P, and I are all there to repress K before it represses E, so if K is gone by itself, then the beginning of the pathway is unnecessary. This shows why not cells in the ectoderm have spikes, because many mutations cause no spikes to occur. If this is happening in each cell, then it is more likely to be smooth. It could also be due to not all cells needing spikes, such as genes being turned off or variable expressivity.